Everybody should take a lesson from Katharine on how to explain this stuff in ways that people understand.
I'm deeply pleased to bring Katharine to the stage. Please welcome her now.
Thank you so much for that kind introduction. And it's great to be here. Yes. Yeah. I have been asked tonight to talk specifically about shaping Alaska's energy future. Now, I am a climate scientist, not an energy expert. I live in Texas, not Alaska. But I think there's a lot that we can learn when we kind of put the pieces together about what energy means to us, what role it serves in our lives, and how important it is to us, both historically as well as currently and in the future. So that's why, for my title slide, I picked 4 different types of energy. How did we get energy thousands of years ago? Pretty much from burning wood, right? How did we get energy, 100 years ago? Primarily from burning coal. How do we get energy now? It's primarily from oil and gas. How will we get energy in the future? That's really the question. You're going to be part of this conversation. So what I want you to do is go ahead and take out your phone. While you're taking it out, you can turn the ringer off. And what I want you to do on your phone is go to polev.com/Texas Tech. That's my university. polev.com/Texas Tech. When you get there, you're going to see the first question. This is an easy question. Are you A, an undergraduate, B, a graduate student, C, university faculty or staff, D, a community member, and E, just visiting? Isn't this fun? Okay, so we have a few visitors. Welcome. I'm a visitor too. Oh, 4% visitors. That's pretty good. 5%. All right. We have a lot of community members. Almost, 60% community members. 20% undergraduate students, a few graduate students, and then 10% university faculty or staff. Okay. All right, so now you've got the hang of it, right? Okay, so the next question is a little tougher. The next question you're going to have to answer with a word. And here's where it gets really tricky. If you really feel compelled to use more than one word, you have to join them with a dot. Do not leave any spaces in between your words, okay? You will see why when you start responding. So when I say energy, what is the first thing that you think of? Any word or words, but they have to have dots in between them. There we go. So the bigger words are the ones that more people said. So a lot of people said power, a lot of people said electricity, a lot of people said oil, sun, and heat, and then the smaller ones are words that that 1 or 2 people said. All right, so we have electricity, power, heat, life, I like that, clean, nuclear, solar, limited, the ability to work, jumping up and down, yes. You must be somebody who has a child. That is definitely the definition of energy. In fact, if we could figure out how to power the energy of small children, we could probably power our entire home with that energy. I'm not quite sure how Pickle and Oprah fit in there, but I'm sure you have a reason. All right. Why is energy so important? We won't use the phones again for a little while, so you can put them down, but keep them handy. Why is energy so important? Well, if we look at the history of human population on this earth, we see that our population kind of went up gradually. Then as we got agriculture, it went up a little more. But then over just the last few hundreds of years, we have seen an incredibly steep increase in human population. And if you look at life expectancy, and this is in the UK where they've been tracking it the longest, life expectancy from the 1700s until now at birth, which is the red line there at the bottom, has doubled. If you were born 300 years ago, your average lifespan, what on earth is happening? It is not like you. Your average lifespan would be 40 years. Just think about that. I'm not going to ask for a show of hands, but if you're over 40 like me, you'd be past your prime. You'd be actually lucky. You'd be counting every day. What's the number one reason why our average lifespan has doubled in just 300 years? It's because of fossil fuels. It's because of the Industrial Revolution, where we figured out how to dig coal, oil, and then gas out of the ground and burn it to power our modern lifestyle. My computer has a mind of its own and is flipping through the slides faster than I can talk. Technology. Just think for a minute about all of the benefits that fossil fuels have brought us. Imagine what your life would be like without a refrigerator, without electricity, without transportation, without the medical advances that have come in the last 300 years. I'm very sure that I would be dead by now if I'd lived in 300-year-old conditions. But it's not only that. What did fossil fuels replace? They replaced animal labor. They replaced women's labor, where laundry was an entire day's activity, and that was back when people only had 2 outfits. It replaced child labor, and most importantly, it replaced slave labor. Fossil fuels and the industrialization they brought with them played a huge role in the Civil War that allowed the North to win over the South, and that led to the freedom of the slaves. So fossil fuels have brought us tremendous benefits, and I want to ask you another question here. I want to ask you this. When it comes to thinking about what fossil fuels have brought us, what are you most grateful for? Now, what you can do here, you don't have to use dashes. You can use as many words as you want with no dots, no dashes, because your answers will just appear here. So when it comes to fossil fuels, what are you grateful for? Maybe you're one of those people who really would like to live. Oh, yeah, yep. Well, I hate to break it to you, but they had beer before fossil fuels. So you would have been okay, especially if you lived in Belgium. I think you would have been just fine 300 years ago. Pizza, I'm not so sure about, but they do have, wood-burning ovens. But heat, survival, medicine, technology, laundry, I'm very grateful for laundry. Also dishwashers. If you've lived, you probably have lived somewhere without a dishwasher. Knowledge, yeah, airplanes. I am grateful for airplanes. I wouldn't be here if it weren't for airplanes today. Life, knowledge, oxygen. So today, if you look around the world, any number here that is 100% or greater means that country produces as much as it needs and then can export. Any country that's less than 100% means it doesn't produce enough to meet its needs, and it's an importer. So we look around the world and we see that there's many countries, including the US, that produce as much energy as we need. And in fact, if we look at oil production, the state I live in, Texas, produces the most. But if you divide these numbers by per capita, Alaska is actually higher. Yeah. If you look at gas production per capita, it's about the same. And then, if you look around the world, you realize that there's places where almost 1 billion people live in energy poverty today, where they do not have access to electricity, they do not have access to clean cooking facilities. And if you look at where those people live, you see that energy poverty correlates with actual poverty, it correlates with life expectancy, and it correlates with issues like hunger and deaths from unsafe water and sanitation and hygiene. So when we look at these maps, we think, how can we prevent more suffering? The answer clearly is fossil fuels. But I would say, not so fast. Now, the answer is not to just pull the plug either. If we pulled the plug on all our fossil fuel use today, that would lead to more immediate suffering than not. But I want to offer you 4 reasons why fossil fuels are not the future anymore, although they certainly have been over the last 300 years, and they've brought us many benefits. The first reason is, if you look at where people live who live in energy poverty, right? So just a second, going back here so you can remind yourself, where people live who live in energy poverty, primarily sub-Saharan Africa, a significant number in Southeast Asia, and then some in Latin America as well. And then you look at where in the world the coal deposits are, for example, coal usually being the most accessible fuel that people first start using, you can see that it's exactly not where people don't have electricity. So they don't have access to the cheapest way that we all started off using fossil fuels. And then when you look at the known coal, oil, and gas reserves left in the world, you see that they aren't located in the places where people need it either. So when people say, well, they should do it the same way we should, what we're actually saying is they should do it the same way that we did, except we can sell them our resources. And we're talking about the richest countries in the world selling the poorest countries in the world their resources. What's the second reason why they're no longer the answer? The second reason is because we recognize that their extraction carries an increasingly heavy burden. Whether it is mountaintop removal, coal mining in the Appalachians that leaves the mountains looking like this. I don't know if you've ever seen a mountain with the top cut off, but it is a very surreal experience. And as my friend Marianne Hitt wrote in this article, mountaintop removal coal mining allows toxic heavy metals to leach into the water supply. Research shows that residents in mining areas, especially mountaintop removal, have higher incidence of cancer, heart disease, kidney disease, birth defects, premature mortality of babies, and many more. We see this here. This is an article from Alaska. When the wind blows in from the vast oil operations, noses run and asthma flares up. Concerns about respiratory illness have risen as North Slope drilling spreads. Impacts on health and impacts on ecosystems, the Prudhoe Bay spill, the Exxon Valdez. And then there's something else that's really interesting that you might not have thought of before. It's the fact that when we pin our economy on one industry alone, we are incredibly vulnerable to fluctuations in cost and price and fluctuations in supply. So in Alaska, the proven oil resources peaked in 1973 and have declined more than 60% since then. The oil production peaked in 1998 and has declined more than 65% since then. And in Venezuela, one of the countries where, I don't know if you've been following the news, but for the last year or so, there have been more humanitarian crises in Venezuela than you can imagine. Closing borders, no electricity, people having to walk miles to just find water in the ditch. Well, part of what happened was their economy was so based on oil that when the prices began to fall in 2008, so we're talking 10 years ago, the tide turned. The largest oil reserves in the world in Venezuela could not stave off economic collapse as lower demand for oil, excessive government spending, sanctions and price controls led to rocketing inflation. The impact on the healthcare system was to pretty much cause it to collapse. And this is not a newspaper article. This is a publication in The Lancet, which is a medical journal. So extraction of fossil fuels carries an increasingly heavy cost that we are starting to recognize today. But it isn't only extraction, it's the combustion as well. Burning fossil fuels produces air pollution. And air pollution has been a problem ever since we first started burning this stuff. The first air quality legislation was in the City of London when King Edward III, I am not joking, passed a law prohibiting the burning of coal within the city limits, including the charcoal burners, when his queen was in residence at the Tower of London. When the queen wasn't there, they could burn whatever they wanted. The penalty for that first piece of air quality legislation was death. We've moved on since then. There are no such penalties as death. Well, Actually, there are, but not the people who typically burn it. 4 years ago, a study found that air pollution kills more than 5 million people around the world every year. And then an update to that study just this past year found that air pollution deaths are actually double. They cause almost 9 million deaths around the world every year. Now, not all of those are from fossil fuels. It's about 50-50 split between people who aren't able to cook inside their home, except with fuels like, brush or dung that pollute heavily indoors. And then the other half is from burning fossil fuels. Here in the US, 200,000 people per year die from air pollution related to burning fossil fuels. Now, just imagine for a second, if 200,000 people in the United States died from bird flu every year, there would be a national uproar. The CDC would be involved. They'd be like, we have to fix this thing. So why aren't we talking about this? It's because we've had it for so long. We've just sort of gotten used to it. We're like, well, the price to using fossil fuels is 200,000 lives a year. That's a pretty high cost. The last reason, though, why fossil fuels are no longer the future is the same reason why party line telephones are no longer the future. Why are party line telephones, and by the way, I actually had a party line telephone growing up. It was quite fun. You got to pick it up and listen in on some conversations. Why are party line telephones no longer the future? Because we have something better. As of 2014, 5 years ago, new energy installations around the world became officially more clean, renewable energy than fossil fuels. 2014 was when renewable energy broke the 50-50 barrier on new energy installations around the world. By 2017, the world saw the largest increase in renewable power generation ever, 9%, and renewables accounted for 70% of new energy installations, 70%. Solar, 55%, wind and hydropower. By 2018, the cost of renewables was closing in on fossil fuels, not only coal. In the US, renewables, solar and wind have been cheaper than coal for a long time in most of the country, not all obviously, but most. But they were starting to close in on natural gas as well. And then the latest news in California is that the cost for solar with batteries, because I don't know if you've heard, but the sun doesn't always shine at night. I seriously get somebody saying that to me once a week, and I'm like, really? Tell me more. They sometimes also mention the wind doesn't always blow, and then I'm like, well, come to Texas. But anyways, in California, a proposal for solar plus battery went in at 1.997, so 2 cents a kilowatt hour, and 1.3 cents for power from batteries. And just for reference, Alaska has some of the most expensive electricity in the country, averaging about 15 cents per kilowatt hour. More than that? I think that's the average. Sorry? 21 cents, okay. So that's basically 10 times this. Now, is solar going to work great in Alaska? Actually, in some places you can use solar quite successfully. Not the whole year. But the big farms that you see down in Arizona and California aren't what you'd look at here. Here, a more diverse approach is best. And so I really like this article. This was an article that was in NCM magazine about a year or two ago, where it talked about what rural Alaska can teach the world. The fact that Alaska has 40% of the world's microgrids. And Alaska has the most diverse set of energy sources of pretty much anywhere that I have ever seen, using stream flow, using geothermal, using biomass, using tides, using wind and sun. In Alaska, people are incredibly creative of ways to get energy. So these are a number of reasons why fossil fuels are no longer the future, but then there's one more. And this is what I actually do. It's the issue of climate change. Now, every time I log into Twitter, and I am not joking, every single day. In fact, yesterday I felt like actually telling the guy, congratulations, sir, you're today's winner, but I didn't. I was nice about it. Every single day on social media, somebody says, don't you know it's been warmer before? And I'm like, how do you think you know it's been warmer before? Because a scientist told you so. Or people say, well, we haven't studied this long enough to be sure, or you socialist scientists are just making it up to line your pockets with government grants. Or, sea levels aren't rising, they're falling, or it's such a tiny amount of carbon dioxide, how could it be warming the planet? It's just a tiny amount of white powder I put in your glass. Surely you'll drink it. Or my favorite, it's cold outside. The latter myth is promoted by many people, including US senators. So every day when I get somebody like this man saying, perhaps Miss Climate Genius can explain how we had an ice age despite zero human interference or emissions contributing towards that climate event, my response, of course, is, that is Dr. Climate Genius. Thank you very much. But what often people say, well, maybe the science isn't certain enough. I mean, coffee's good for you, then it's bad for you. Then it's good for you, then it's bad for you. And then chocolate's good and bad and good and bad. And then what about butter? And then margarine and then butter again. I mean, you've heard these things, right? It gets to the point where you hardly know what to eat except raw vegetables. And then you hear about the person who ate too much butternut squash and turned orange. Real thing. Google it. So get out your phones again and let me ask you all a question. This is multiple choice. How old is climate science? The basics have been understood since the 1800s, or scientists have been talking about it since the 1960s, or since Jim Hansen, a famous climate scientist, testified to Congress in 1988, or it was invented by Al Gore. Because he wanted to do a movie, he wasn't quite sure what to do it about, so he created climate change to make the movie. Okay. We have A surging into an early lead, but we have D sort of inching up on it. Sort of feels like election night here. Voters for B do not quite give up yet. There may be more votes coming in. There's a few counties they haven't reported yet. Oh, see, coming up a little bit, but you know what? I think it's getting to the point where we can call it. You all are right. This is the man in the 1820s who figured out that our atmosphere is keeping our planet almost 60 degrees Fahrenheit warmer than it should be. And by the 1950s, this man, John Tyndall, had identified the gases. He identified specifically that it was what they call coal gas, which is methane, carbon dioxide, and water, that were wrapping a blanket around our planet, keeping it warm and habitable for life when otherwise it would be a frozen ball of ice. 1950s. And not only that, but he connected it to coal mining. He actually figured out that by mining coal, they were producing more of this stuff. Now, at the same time, on the other side of the Atlantic, there was a woman called Eunice Foote. I'm not totally sure this is a picture of her. Her 7th grade niece and I have been searching for pictures for 3 years. So people have actually gone to the Smithsonian archives and they found pictures of her husband, of her daughters, and they found one picture they said might be her, so I'm going to use it just so you can sort of see what she probably would look like. She was an amateur scientist because there weren't a lot of places in those days where women could go to school, let alone to become a scientist. But she was an early advocate for women's rights. She was a signer of the Seneca Falls Declaration. Her husband was a judge, and together they did science experiments in the backyard. So one day she decided she was going to put out glass jars in the backyard and fill them with different gases. How do you think she filled a jar with CO2? Breathing into it. Exactly. And she put them out in the sun, and she measured how much the air in each different jar heated up as it was exposed to the sun. Now, her experiment was not as sophisticated as Tyndall's, who had the advantage of a full education of postdocs, of the Royal Society, of the access to the latest experimental techniques of the age. So she wasn't able to separate out infrared from visible energy, But she found that CO2 increased more than other gases in regular air. And so in the paper that she wrote that was presented at the meeting of the American Association for the Advancement of Science, which still exists today, and I serve on one of their advisory boards, in the meeting in 1856, she wrote a paper that said, if carbon dioxide levels were higher on our planet at any time, the Earth would be warmer. 1856. So we knew almost 200 years ago that as our population was growing, so too were our carbon emissions. The more coal, gas, and oil we dig up and burn, the higher our emissions are. And if you look at total emissions by state, Texas is number one. I know it's the same color as California here, but the actual numbers are quite a bit higher than California. But I have some bad news for you. If you divide it by the number of people in the state, we produce a lot of these heat-trapping gases. And why do these heat-trapping gases matter? I can explain it to you in a 60-second cartoon. Here we go. Our planet, there's our happy planet. Our planet has a natural blanket of heat-trapping gases. The sun's energy shines down and pretty much goes through this blanket like a window. The Earth absorbs the energy and heats up, and it re-emits heat or infrared energy. And this blanket of naturally heat-trapping gases traps that energy, reflecting half of it back down and half of it back up, keeping our planet over 60 degrees Fahrenheit warmer than we would be otherwise. And that is why we have life on this planet and we are not a frozen ball of ice. So if this is an entirely natural and an entirely good thing, what's the problem? The problem is that by digging up and burning coal and gas and oil, we are wrapping an extra blanket around the planet that it does not need. And just like my grandma used to sneak in every night when I stayed at her house and put an extra blanket on me, and I would wake up sweating saying, Grandma, I didn't need the extra blanket. In the same way, we're wrapping an extra blanket around our planet, and that is the reason why our planet is running a fever. From year to year, our temperature goes up and down, but decade by decade by decade, our planet is warming. And do you know how long we've known that our planet is warming as a result of this extra blanket that we're wrapping around it? Since the work of Guy Callendar in 1938. He was a British engineer who, in his free time, apparently people had a lot of free time in those days, he rode around the world and collected weather station data from around the world and averaged it all up to a global average and actually showed that the world was warming. And in his paper that he published in 1938, it's actually quite entertaining. He says, essentially, you're not going to believe what I have to tell you, but I will show you through data and analysis that our planet is warming due to the artificial production of carbon dioxide. 1938. We also know since then that it can't be the sun because the sun's energy's been going down the last 40 or 50 years, not up. It can't be natural cycles like El Nino because all they do is move heat around the planet. They don't cause it to increase. That would be violating conservation of energy. And it can't be the natural cycles in the Earth's orbit because the next thing coming there, according to our orbital calendar, was another ice age. But I have good news for you. We have indefinitely postponed the next ice age. And we are heading full speed in the opposite direction. Jurassic Park is a lot closer now than the next ice age movie. We also know through looking at natural thermometers or proxy data from tree rings, ice cores, pollen records, stalactites, even written historical records, that of course it's been warmer before. We know that there was this thing called the medieval warm period, which we only know about because we're focused on Western Europe. If you lived in Siberia, it was actually the medieval cold period at that time. But we also know that this was a natural cycle, moving heat from one place to the other. One place gets warmer, another place gets cooler. We know that today our planet looks very different. And even though there have been tens of thousands of peer-reviewed scientific publications on a changing climate and the human role published since the 1800s, there's still a few papers published every year, and they make big headlines in certain news outlets because they say, oh, climate isn't changing. We found out it's really cosmic rays. Or, you know, the data's just been adjusted and it doesn't actually show any warming. So 3 years ago, some colleagues and I, we took 38 of the most recent studies. There was only 38 as opposed to, you know, hundreds on the other side. We took the 38 who have been published recently, whose results oppose the idea that climate is changing and or humans are responsible. And we, and by this I mean primarily our lead author, Rasmus Benestad, with the rest of us helping. I think Rasmus has the same amount of free time as Guy Callender did back in the 1938. We recalculated each one from scratch. You know how much work that is? And he put his code online so anybody could check it. And you know what we found? In every single one of them, we found an error, a false assumption, a missing factor, a flaw in logic. We found some type of mistake, at least one, that if it were corrected, it brought the results right in line with the existing scientific consensus. So we really are sure. We have known for more than 100 years that trace gases in the atmosphere are the thermostat of the planet. Burning coal, gas, and oil produces more of them. That's the reason the planet is warming. And therefore, and this is really important, therefore, our future is in our hands. The biggest uncertainty in the future is the choices that we make. But even still, you know, we hear this stuff every day. So let me ask you, do you think people really have a genuine problem with or genuine objection to nonlinear fluid dynamics and radiative transfer? I'm pretty sure they don't, because if they truly did, and that's the fundamental physics you need to understand the climate system, which we've understood since the 1800s, if they truly had a problem with basic radiative transfer that we've understood since the 1850s, and with nonlinear fluid dynamics that we've been able to model since the 1950s, then there'd be a lot of websites claiming refrigerators don't actually work, and stoves do not heat food, and airplanes absolutely do not fly, because it's the same physics. We would have to throw all that in the trash. But here's the thing. People don't really have a problem with that science because they happily use something else that's based on the same physics while trashing the climate models and saying that they're garbage. So then we think, okay, well, maybe it's the fact that people just don't know enough about science. Maybe they just don't realize it's the same physics. And if we told them it was the same thing, then they'd be like, oh, okay. Well, this assumption, which many of us scientists and educators fall prey to, is known in the field of education as the knowledge deficit model. In other words, we have a blank slate in someone's brain, and all we have to do is come along and give them the right information, and they'll say, thank you very much. They'll write it on the slate, and we'll be good to go. Now, before you dismiss this too quickly, for some things, this absolutely applies. Like, what if somebody came to you and they said, we've learned something new about black holes? You'd be like, oh, okay. I mean, you might write it on your slate and forget about it, but you'd be fine with whatever they told you about black holes, probably. I mean, unless people have like a real objection to... No? Okay. So for some things, this works just fine. And for example, in mathematics, when you teach somebody that 2 + 2 = 4, you don't have a lot of people arguing with you over that. If you are a teacher of young children, you will occasionally find one who will give you some trouble over it. But in general, people don't put up a fight when you tell them that 2 + 2 = 4. So here's where the social science comes in. Not the physical science, but the social science that explains how people think. This is Dan Kahan from Yale, and he did a really interesting study 5 years ago. He said public apathy over climate change is often attributed to a deficit in comprehension. People don't know enough science. So if they don't know enough science, what's the answer? More science. Maybe our reports don't have colored graphics. Maybe we need to add some animations to our reports. Maybe we have to, how about videos? Oh, and then I've heard like interactive web graphics are really good. So people just keep producing more and more reports, and if you piled up all of the IPCC reports, their assessment reports and their special reports, they would be taller than the flag post. And they would be tens of thousands of pages long. But this is what social science is for. So they conducted a study to test this, and guess what? They found no support for it. In fact, people with the highest degree of science literacy were not most concerned, they were most polarized. So Dan went on to invent a scale he called ordinary science intelligence. In other words, a way to just measure people's ability to understand quantitative reasoning, which is just one form of intelligence. There's many others. And then he asked people, do you agree there's solid evidence of recent global warming due mostly to human activity such as burning fossil fuels? Now, just to step aside for a second here, my answer to this statement would be, I disagree. Why? Because I know that according to natural factors right now, the net impact of natural factors right now would be cooling. So I personally would have a problem with mostly. I would be like, no, it's not mostly, it's all, and then some, because we should be getting cooler. But I don't think that's the reason why people answered no to this question. What he found was he found a pretty weak correlation between intelligence and probability of a correct response. A bit of a correlation, but weak. So then he took this data set and he divided this data set in half. He did not divide it in half by gender. He did not divide it in half by level of education. He did not divide it in half by age. He divided it in half by one thing. Yeah. And again, remember, the x-axis here is intelligence. So what did he conclude? He concluded that the smarter we are, the better we are at picking just the information that shows why we're right. And we all need to take this as a caution because we all do this somewhere, somehow. You ever had an argument with anybody? What did you do? Did you look for points that supported your argument or dismissed your argument? You'd be looking for points that supported your argument, right? And the smarter you are, the better you are at finding points that support your rationale for how to roll the toothpaste, which car should be parked in which order, whose turn it is to clean the kitty litter, and is climate changing. So if the science has been around long enough, and if more science education is not the problem, what are the real myths that we believe? Well, the real myths that we believe are actually pretty clear once you start listening to the subtext. And first of all, I'm going to give you the subtext from the senator who brought the snowball onto the Senate floor. He said the same year, he said, do you realize I was actually on your side of this issue when I first chaired that committee and heard about it? I was on your side until what? Till I saw it snow? No. I thought it must be true until I found out what it would cost. We believe that the costs of fixing climate change are to destroy the economy, to return to the Stone Age, and to submit ourselves to loss of personal liberty, government control, letting China run the world. We believe that the solutions to climate change pose an imminent threat to our lives and comfort. That is what we really, truly do believe. And I'm going to be perfectly honest with you, I've got some of that too. So get out your phones again, and I'm going to ask you, when it comes to climate solutions, what are you most concerned about? Are you worried that it would lead to bigger government and over-regulation? That it would lead to loss of personal freedom to make your choices, like in Fairbanks, burning your wood stove, in Texas, driving your truck? Are you worried about a reduced quality of life? I fly to see my family, and I want to see my family. Are you worried about the economy taking a hit? A job loss for you, your family, or friends? Being on the same side as Al Gore. I include that, and I'm not picking on Al Gore. I think he would take this well. But I have literally given talks in Texas where somebody came up to me afterwards and they said, everything you say makes sense, but I can't agree with you because if I agree with you, then I'll agree with Al Gore, and I can never do that. So this is real. This is not a joke. This is a real, genuine objection. And I sort of understand that because I definitely have some people in my life who, I would rather not agree with. All right, so what do we have here? We have about 12% bigger government, about 10% loss of personal freedom. We have, I hope I didn't bias the results. I mean, C is my answer. About 50% or more reduced quality of life, then the economy taking a hit, job loss, and being on the same side as Al Gore. You are not alone. So this is one of the genuine fears that we have. Why? Because our civilization is built on fossil fuels, right? It is a genuine fear. What's the other real problem that we have? The other real problem is this. This is a really cool map from the Yale Climate Opinion Survey. It asks people, do you think global warming will harm plants and animals? Actually, there we go. And orange is more than 50%, blue is less than 50%, and the darker the orange, the more people say yes. So pretty much across the country, most people, including in Alaska, you can see Alaska down there, most people would agree that global warming will harm plants and animals. It will harm future generations. It will likely harm people in developing countries. It's starting to get a bit bluer here, but it's still pretty orange. It will harm people in the US. Well, a little bit more blue, but still a lot of orange. And then they asked another question. They said, do you think it will affect you? Yeah. And if you're wondering what the orange counties are populated primarily by one or two of the most concerned people groups in the U.S. about the impacts of a changing climate. Group number 1 is Hispanic Catholics. Group number 2 are tribal nations. Here we have Alaska. Alaska's slightly lighter blue, but it is less than 50%. Why is that? Because when somebody says global warming, now you need to answer this question with a dot in between the words, okay? This is one of those ones where one word or dot in between the words. When somebody says global warming, what is the first picture or image that pops into your head? Go. All right, you had me slightly worried there because I've gotten the same result from every single audience I've ever talked to across North America and Europe. But it's snuck in there. Yep, it's sneaking in there. The number one thing that most people think of when you say global warming is the polar bear, preferably sitting on a piece of ice looking sad. There is a meme somebody created of a polar bear holding a banner that says, "Help me, Al Gore." But in reality, who's on the iceberg? Exactly. We are the ones on the iceberg. So how do we tackle the real challenges? Question number 5. This is the last question. We believe that the solutions pose an imminent threat and the impacts do not. But in fact, it is largely the opposite. Let's look at the impacts first. Wherever we live, we are at risk from extreme weather and climate events naturally. The chances of rolling a double 6 exist naturally. What is a double 6? A bad wildfire season, a crazy heat wave, a heavy rainstorm, a very strong storm, a drought, a cyclone, a hurricane, a blizzard, an ice storm. We always naturally have a chance of rolling a double 6. But as the planet warms, decade by decade, it's sneaking in and it's changing another one of those numbers into a 6. So all of a sudden, we're rolling double sixes a lot more frequently. The city of Houston gets its third 500-year flood in 3 years. That is not a 500-year flood anymore. And then they get Harvey, and Harvey was a set of double sevens. And they're like, who put the sevens on the dice? We care about a changing climate because it exacerbates the risks that we face today. Where I live in Texas, we get really bad floods, but you know what? You get floods too. And as the world warms, heavy precipitation is increasing because warmer air holds more water vapor. When a storm comes along now, there's more water vapor for that storm to pick up and dump on us than there was 50 or 100 years ago. So since the 1950s, this is since the 1950s until now, we have seen significant increases in the frequency of heavy precipitation across the U.S. And I'm sorry, Alaska is, I think, 12 to 16%. It somehow got cut off there, and that was an oversight. We see hurricanes and cyclones in Texas, and we see those types of things up here too. In a warming world, we are not seeing more frequent hurricanes or cyclones, but we are seeing that there's a lot more rainfall associated with them. It's estimated, for example, 40% of the rain that fell during Hurricane Harvey would not have happened if the same storm had occurred 100 years ago. And there was a very serious hurricane in 1900 called the Galveston hurricane that hit the same place. They're intensifying faster because they get their energy from warm ocean water. More of them are stronger. They're moving a lot more slowly. Remember Dorian? It camped out over the Bahamas for almost 2 days. They're getting bigger. They're moving northward. Did you know when Dorian hit Nova Scotia, it was a Category 2 hurricane? And of course, sea level is rising. In Texas, we have droughts and we have water shortages. And in Alaska, you do too. Well, as the world warms, our soils are drying out. Our droughts are getting stronger, longer, and more intense because we have a high pressure system sitting over us during a drought that directs the storms away from us that would gather all that water vapor together and otherwise dump it on us. So we're seeing that our droughts, when they occur, as they do naturally, they're more intense in hotter conditions. In Texas, we actually have record-breaking wildfires too. And of course, you know you do in Alaska too, because that word fire beat out the polar bears. But did you know across the western U.S. that without a changing climate, there would have been 11 million acres burned? But with the changing climate, since the 1980s, there's been almost double that area burned. In other words, there's a lot more sixes on the dice now. What else is happening in Alaska? The permafrost is thawing. The sea ice is melting. Last winter's temperatures up north were so warm that the weather stations thought they were errors and they flagged them as false data. The term is no longer climate change, it's climate changed. This summer was crazy extreme weather. The 10 wettest months on record in Fairbanks, little precipitation in Anchorage, and crazy fires. We see the impacts of a changing climate right here in the places where we live, and they matter to us. In November, you have the author of this report coming. This is a fantastic report. You can find it online. It's just 16 pages, and it's really easy to read. It talks about all the records that have been broken in Alaska just over the past 5 years. It talks about how the area damaged by spruce bark beetle started off at about 20,000 acres in 2015, and it's now up to 600,000 acres, just 4 years later. Wherever we live, we are impacted by a changing climate, and not just us. Remember this map? I didn't show you one more map, and that is the map of who is most vulnerable to the impacts of a changing climate. When people are already hungry, when they already do not have access to clean water, when they're already dying of diseases that nobody should be dying from in 2019, climate change is, as the military calls it, a threat multiplier. It is taking those issues and it is making them worse, and that is not fair because they have done the least to contribute to that problem. So I want to ask you again, take out your phones. This is one of those connect your words with a dot. What climate impacts are you most concerned about? It can be something here, it can be something abroad. When it comes to climate change, what are you most concerned about? Water. Our water resources in many places are becoming increasingly strained. Nearly 1 billion people depend on glaciers, actually, for their water supply, most of them in Southeast Asia and Latin America. In some places, they have more water than they know what to do with now, but soon those glaciers are drying up, as they already have in Lima, Peru, where some of the water from that glaciers to Lima used to flow through channels built by the Incas. But their main glacier ran out a number of years ago, and they've had to build a desalination plant, which is a lot more expensive than free water from the glaciers. Poverty, life, food security. It's estimated since 1980 that on average $5 billion worth of crops have been lost every year due to the impacts of a changing climate, and most of those crop losses are happening in countries where people live off $1 or $2 a day. The nutritional content of our food decreases as CO2 increases because the plants grow faster, but the nutritional density decreases. So what can we do in the future? We still need energy today more than ever, but we need to go to net carbon zero as soon as possible. There's no magic threshold. There's no 1.5, 2 degrees, 12 years, or else we all die. It's simply the fact that just like with cigarettes, the more cigarettes we smoke, the worse the damage. The more carbon we produce, the worse the damage. There is a very real cost associated with each additional gigaton of carbon we produce. Oops, I wiggled this. I touched it, I shouldn't have done that. But we need solutions that are practical and positive and beneficial, that don't destroy the economy, that don't throw people out of work, that actually leave us better off rather than worse. Well, here's the good news. When the Yale Climate Opinion Maps asked people, do you support funding research into clean energy? It turns out the whole country does. Isn't that crazy? Do you support taxing fossil fuel companies? Even in Alaska, it's well over 50% in every region. Do you support requiring utilities to produce 20% of their power from renewable sources? Pretty much yes. And did you know that across the lower 48, the cheapest new electricity up the whole middle of the country is wind? On the sides, it's solar. The orange is natural gas. Now you might say, oh yeah, that's because that stuff is so subsidized. And actually, yes, that is the reason why we have orange on the map. What, you might say? Why is that? Because the subsidies on fossil fuels for the United States alone exceed the Pentagon's budget. They are on average about 50 times the subsidies on clean energy. And so that's why, to correct this imbalance, people are proposing carbon pricing bills. And here's the crazy thing, they are being proposed by bipartisan partnerships. Did you know that a bipartisan partnership could exist in 2019? I mean, this really is a miracle. If you don't believe in miracles, this is a miracle right here. And not only that, they are being proposed by conservatives like James Baker, George Shultz, Bush-era conservatives, saying there's a conservative case for putting a price on carbon. And if you put a price on carbon, this is what the electricity cost would look like across the lower 48. Isn't that crazy? Things are changing even in Texas. I live in Texas, where there's the biggest Army base in the country. No surprise. I know there's big ones here too. But Fort Hood went with wind and solar over natural gas 2 years ago because one reason only. It would save taxpayers $150 million. Dallas-Fort Worth Airport is the first carbon-neutral airport in North America. We have over 30,000 jobs, almost 35,000 jobs in wind and solar energy in Texas. If you look around the world, you see that the richest company in the world, Walmart, is going to be 50% clean energy by 2025. Apple is already 100%. And in countries around the world, change is happening. Where do you think the biggest solar farm in the world is? Morocco. Bet you didn't guess that. Where's the biggest offshore wind farm in the world? The UK. Which country has way more wind and solar energy than any other country in the world? You probably do know the answer to this one. China. Not the US. US is number 2, but a pretty distant number 2. And did you know that there is a renewable energy atlas of Alaska that was just reissued in 2019 that tells, yes, really cool. It was originally published in 2016, just released this year, and it goes through and describes all of the projects that have been funded across Alaska that are incredibly creative, incredibly innovative, incredibly practical, very personalized. It has a map of where they all are and what type they are. You've got biomass, biofuel, geothermal, heat recovery, hydro, ocean or river, solar, transmission, and wind. You've got projects like this where they're taking energy out of the stream, replacing most of their diesel. You've got village-scale wind turbines. You have, unfortunately had, but you had the REAP, which, due to the funding it received, which was almost $1 billion, they saved $110 million worth of power. They put in 60 projects around the state. They educated 4,000 students. The world is changing, and Alaska is changing too. So when we look to the future, we still need energy. Other people who don't have it need energy too. But when we look to the future, that energy is going to be different. Because just like my great-grandma, this is my great-grandma Lucy when she was just married, just like my great-grandma Lucy, was not investing in horses and buggies. But 10 years later, with her young family, this was the family portrait. In the same way, our future is no longer horses and buggies. It is no longer the types of transportation that served us well. It is no longer the types of energy that served us well in the past, for which we are grateful. When we look to the future will look different. So I have one last question for you, and this is my last question. When it comes to the future of energy, what are you most excited about? Use the dot. I like that one. That's a good one. The cheapest kilowatt is the one that you never use. I'm also excited about living. Definitely. Opportunities. I like that one. I'm very excited about opportunities. Sustainability, innovation. Yep. Surprises, good surprises. I'm excited about those. I'm excited about, I would like to have more skiing. In fact, in all seriousness, there's a really cool organization called Protect Our Winters that has a lot of Olympic athletes. Oh, okay, yes. And they are all about protecting our snow for skiing. I am a skier, so I feel very strongly about that. Clean air. Oh, more, okay, you're upvoting more skiing. I see what that did. Now, don't try to suck up to me. I'll still like you if you don't ski. Tesla, I can tell you my husband's super excited about Tesla. He really wants a Tesla. Water, living, health, creativity, less pollution. We can be excited about the future, and this is what we need. We need hope. Fear gives us the adrenaline we need to run away from the bear, even though you know you shouldn't really run away from bears. But fear will not take us to fix this thing long term. To fix climate change long term, we need hope, and hope has to be powered by the inspiration of a better future. So when you leave tonight, think about, what does that better future look like? How can we talk to people about how climate change is affecting us in the places where we live and what we can do to fix it? Because when it comes to a changing climate, as I say in my TED Talk, the single most important thing that every single human in this room can do is talk about it. Because if we don't talk about it, why would we care? And if we don't care, why would we ever do anything to fix it? Thank you. Thank you so much. Now, if you need to leave, go ahead and leave now. But if you want to stick around for another 6 or 7 minutes, I am going to take a few questions. How am I going to do it? Like this. No dots needed. You can type in your full question, but try to keep it to just no more than 2 lines. And then here's the cool thing. You can upvote other people's questions. So I'm going to answer the top 5 questions. So if you have a question, go ahead and enter it in. And even if you don't have a question, go ahead and upvote the questions that you want me to answer. So we have 10 votes at the top. That's a pretty clear, 12. Okay, excellent. 13, it's climbing. Man, this is the first time that's ever been the top question. First time ever. Ever in 10 years. But I can answer this one. Nuclear energy does not produce heat-trapping gases. Nuclear energy does produce waste. In some places, keeping nuclear going is one of the best ways to produce clean energy. In other places, trying to install new nuclear has been so cost prohibitive that costs of electricity have skyrocketed and entire projects have been axed. So nuclear, I think, is absolutely part of the mix, but it has to be done in a cost-effective way. And that is why, when it comes to new technology, I'm actually super excited about something that I didn't mention. Here we go. There we go. I'm super excited about the fact that there's some new technology coming along when it comes to nuclear. Idaho National Labs has created something they call mini nuclear. It's small modular nuclear, that's the picture of it right there, that fits on the back of a truck. So it's a lot more flexible, it's a lot more cost effective, and it's a lot more safe than traditional nuclear. So if we can do it at cost, and if it is part of a cost-effective mix for a given location, absolutely. We have to figure out what to do with the waste, but frankly, if we don't fix climate change, we're not going to be worrying about what to do with the waste. I'm also actually, now that we're here, I'm super excited about this one on the right. Did you know that there's a Canadian-Swiss company that's figured out how to suck carbon out of the air and turn it into fuel? It isn't cost effective yet, but with the price on carbon, it'll be getting a bit closer. That would be truly carbon neutral. And if you make fuel out of something that sucked the carbon out of the atmosphere pretty soon, like algae, biomass, or this, then it's carbon neutral. And did you know that United Airlines is already running flights out of LAX on biofuel? Yep. Same engine, no modification to the engine whatsoever. Yeah, I know. So things are changing. Okay, so that was question number 1. Now, what have we got? Nuclear energy's moved down. Now we've got, how can Alaskans who have a huge carbon footprint get their footprint down? Well, the first thing to do is to step on the carbon scales. And when I did that a number of years ago, I'd always been told that my diet was the biggest part of my carbon footprint. Well, guess what? It's not. For you, maybe it is. But I'm not really a big meat eater. I like to eat meat occasionally, but it's not, I don't eat a steak with breakfast, lunch, and dinner. So I stepped on the carbon scales and I found out that my travel was the biggest part of it. So I figured, what could I do to reduce my travel footprint? At the same time, a guy from Houghton College, which is a very small Wesleyan college in upstate New York, 2 hours from Buffalo and anything else down a dirt road, he emailed me and he said, we'd love to have you come to Houghton College, and I want to do an experiment where I test the students before and after to see if your presentation actually changed their minds or not about climate change. Because it's an evangelical college, and so there's a lot of people who come in thinking, this thing isn't real. So I said, well, could we add to the experiment, because I'm really concerned about traveling so many places, could we have a thing where we also test whether me in person or me video is more effective? So he said, sure. So I recorded my talk the day before as near word perfect as I could humanly do, and when students arrived for our talk, they were funneled into either me live or me video. And then they were tested before and they were tested after. So first of all, the first good news was that there was a statistically significant difference on almost every question on, we used the 6 Americas of Global Warming survey. There was a statistically significant improvement on almost every question when they attended my talk, which was like, whew, I'm not wasting my time. But you know what? There was no statistically significant difference between the two groups. None. So I was like, all right, because now I can do videos. So I started doing our Global Weirding series on YouTube. This is the one that talks about fossil fuels, which is what I talked about today, because way more people watch YouTube than will come to see me in person. And then when people call me to give a talk, I say, first of all, could I do it virtually? And most people say, I don't know, we've never had anybody do that. And I say, well, I would really like to do it. In fact, I can't go somewhere if I don't have at least 5 events in the same place. So I have to do it virtually or nothing. And all but one university so far have said, okay. So I do it virtually, and now 75% of my talks are virtual. And when I do travel, like I'm traveling here, I ask people to pack my schedule with as many events as possible because I want the carbon footprint of each event to be as small as possible. So I calculated that with the 29 events I'm doing here, which don't even include the fun stuff like hiking, it's as if I took my little car and I drove to Dallas and back to do 4 events. It's the same carbon footprint per event. But in addition to that, I also went to climatestewards.org, and I offset my emissions with an organization that I know personally I trust, who works in 8 poor countries to do clean cook stove programs, regenerative agriculture that puts carbon back in the soil, and reforestation to offset my emissions. And then I did one more thing. I calculated that if 10 of the people that I talk to or that hear me while I'm here in Alaska, in Juneau, Anchorage, or Fairbanks, if just 10 people decide to reduce their own carbon footprint by just 10%, that would actually offset my whole travel too. And so far, I've actually got 2 people signed up. So in terms of a carbon footprint calculator, actually, let me show you one that I really recommend strongly. Just a second. This is why I love having my own computer. I can pop things up for you and show you. In terms of a carbon footprint calculator that I recommend, there's a couple of different ones. There's a good one that University of California at Berkeley has. And then, let's see, I think I have a slide showing one here. In just a second. Yes, this one I like right here. It is footprintcalculator.org. It's pretty easy to remember. So a good calculator would not only tell you what part of your life, transportation, housing, diet, travel, not just what part of your life produces all the heat-trapping gases or more, it will also tell you what to do about it, how to reduce. It will give you solutions. So this is one of my best resources, footprintcalculator.org. Electric planes for short-haul flights are in development. But you can't do long-haul flights with electric planes because the battery's going to be too big. For long-haul flights, biofuel has a real possibility, but not biofuel like ethanol that takes more carbon to grow than it does to harvest, but biofuel that uses algae that you can grow in giant bags, or agricultural residues, or by just sucking it out of the air, and you can use it in the exact same engine. You don't have to modify the engine at all. So there is a future for sustainable air travel, but it will be powered by removing the subsidies on fossil fuels and or putting a price on carbon, because right now our market is imbalanced and fossil fuels are artificially a lot cheaper. And industry is driven primarily by price. All right, how do you respond to people who seem driven by polarized ideology? Well, I live in Texas, so I have a lot of these conversations. And what I say is, well, let's actually talk about the real problem, because the real problem is not the science. The real problem are the solutions. As a scientist, I'm solution agnostic. I'm for anything that cuts carbon and doesn't hurt people. So I do a lot of research, and I find out that it turns out that there are libertarian solutions to climate change. There are free market solutions to climate change. There are conservative solutions to climate change. There are bipartisan solutions to climate change. There are financially beneficial solutions to climate change. Not for everybody, because the big fossil fuel companies have to transition to different sources of energy in order to benefit. But there are, and so for example, I just participated in a new initiative I want to share with you. Here, Again, this is why it's nice to have my computer. I want to share with you a new initiative that I just participated in, and it's called newclimatevoices.org. And what they have is they actually have little videos and then resources and links to Republican congressmen, to, here we go, a retired Air Force general, to a libertarian, where they talk about what their solutions are to this problem, because a thermometer is not Democrat or Republican, but the solutions are. And we need solutions across the entire political spectrum, because we're never going to agree on the politics, but we can agree that there is a problem, humans are responsible, the impacts are serious, and we do need to act. I also have a global weirding episode that addresses this in addition to my TED Talk. Actually, let me show you. Our global weirding episode, global weirding, is called If I Just Explain the Facts, They'll Get It Right. Watch this episode too, because this explains how our real problem is not the scientific facts. Our real problem is solution aversion. We don't understand that there are solutions that we can get on board with, being the exact same person that we already are. We're afraid we have to change who we are to agree with this issue, and we don't. Because all we have to be to agree that climate is changing, humans are responsible, the impacts are serious, and we do need to fix it, all we need to be is a human living on this planet, and most of us are that. All right. Last question. How can a minor help with this issue? Well, you know what? Kids are doing amazing these days. They're doing more than adults, it seems like. Yes. I was talking to kids earlier today, and when I was talking to them, I knew that they were probably going to think, well, you know, I'm just a kid, what can I do? So I actually went and I found some examples of what kids have done. And of course, we also have a global weirding episode on it too. And it was one of the most inspirational episodes that we made, because it actually talks about, and I'll show you this here, it actually talks about all of the incredible things people are doing, like a girl who has started growing algae under her bed, and then her mother kicked her out to the garage, and she ended up inventing algae biofuel and winning the Intel Science Prize for it. How cool is that? Now, where did I put my kids here? I'm losing my kids. There they are. So this is our global weirding episode talking about what kids are doing. There are amazing things happening in green schools. There are young children, including one in Alaska, who are suing the federal government for failing to protect their future. There are the kids' climate strikes that are led by teenagers. There's the fact that a new study from North Carolina found that educating children, they're more effective ambassadors to their parents than anybody else. So kids are amazing. And when it comes down to talking about climate change, which I really truly believe is the most important thing we can do, because when you look at the Yale climate opinion maps, the darkest blue map is, do you ever talk about this? Every single one of us can talk about it. It turns out kids are even more effective than adults at talking to their parents about this issue. They found, that study, that daughters had the biggest impacts on their conservative dads. So there are a lot of cool things out there. I hope I've offered a few thoughts for you to think about, a few new ideas you might not have had, a few resources that you can look up. But if you're interested in more, and if you're interested in more on a very different topic, please feel free to come out tomorrow night at 7 p.m. at, what's the name of the church? Faith Community Christian, 7 p.m. for more about science, faith, Christian values, and how they relate to the impacts of a changing climate. Thank you.